Hi, this is Miss Logan. Today I'll be talking about characteristics of mechanical waves. So what is a wave? A wave is a really general definition. It is anything that is a disturbance in a medium. Okay? So we often hear this word medium, but we really don't know what it means. So a medium is a substance that carries a wave. So there can be a lot of different things. It could be water, air, slinky, a stadium. There's a lot of possibilities for what this medium could be. So the basics about waves. Waves are any particles that are interacting on this medium. So for an example, this could be coils in a slinky or people doing the wave at the stadium, like the picture right here. Waves move energy, not actual matter. Particles are moving from rest and then coming back to rest. So if you think about a wave at a stadium, people are standing up and then back down. They're moving energy across the stadium. So there are two different types of wave we're going to focus on. The one we're going to see the most is a transverse wave. So this is when a wave moves perpendicular to the direction that the wave is moving. So this could be a slinky or the ocean. If we see this example at the bottom, you'll see that the movement is to the right, but the particles are moving up and down. So think about a wave at a stadium. Once again, it's moving around the stadium, but people are just standing up. Then we have our longitudinal waves. We're not going to see these as much as transverse waves. These ones move parallel to the way the wave moves. So if we look at this example right here, the direction of energy is to the right, and the particles are also moving back and forth. We see this mostly with sound waves. So we can also classify waves into electromagnetic waves and mechanical waves. Electromagnetic waves are waves that are transferring through a vacuum. So this is like light or radio. It can travel through space. Mechanical waves cannot transfer through a background. So this could be a jump rope, water, or slinky. These are waves we're going to see the most. We normally don't see any electromagnetic waves. So there is some essential vocabulary that we need to learn when we're talking about waves. I'm going to focus on the big ones here. First, we have our amplitude. Our amplitude is the length from our equilibrium in the middle all the way to the top of the wave. Our crest is the very top of the wave. Our trough is at the bottom of a wave. Then we have our wavelength, which is this distance from crest to crest. I recommend in your notes actually copying down this exact image. So when we're talking about longitudinal waves, we have a little different vocabulary. First, we have our compressions. So this is where the particles are moving close to one another. Then we have rarefactions. This is where they're moving farther apart. So this example of a slinky being pushed to the right is a really good example of your compressions and rarefactions. Our final bit of vocabulary is talking about frequency, period, and speed. So my frequency is how often particles vibrate when they're passing through the medium. We measure this in something called hertz. The period is what we refer to the most. So this is the time it takes for a particle to complete one cycle. We'll always see this in seconds. Then we have the speed. So it's the distance the wave travels over a period of time. What we're going to be focusing on are these three equations at the bottom. Okay? So period equals 1 over frequency, frequency equals 1 over period, and speed equals wavelength, which is distance, over the period, which is time. So let's look at a few word problems with period, frequency, and speed. So free to the fly flaps its wings back and forth at 121 times each second. What is the period of the wings flapping? So we know this equation is period equals 1 over frequency. Remember, our frequency are this number of times per second. So the period is 1 over 121 seconds. So an example like this, it's totally fine to just leave your answer in fraction form. Okay, so a wave has a wavelength of 2 meters and has a period of 8 seconds. So what is the speed? Remember, our equation is our wave speed equals the wavelength over the period. That's my distance over my time, just like a regular problem. So I have a wavelength of 2 meters over a period of 8 seconds. So my speed is 1/4 meters per second. So please make sure you have all your vocabulary written down because we're going to be using it a lot in class for this unit and future units.